Hello students, so this is JEE Advanced PYQ. The question is saying a ball is thrown from the location x0 y0 which is actually 0 0 from a horizontal playground with an initial speed v0 at an angle theta naught from the x-axis, positive x-axis. The ball is to be hit by a stone which is thrown at the same time from the location x1 y1 is equal to L0. The stone is thrown at an angle 180 minus theta 1 from the positive x direction with a suitable initial speed for a fixed v0. When theta naught theta 1 is 45, the stone hits the wall after time t1, and when theta naught theta 1 is 60, it hits the wall after time t2. In such a case, find the value of t1 by t2 whole square. So first of all, we will draw the condition how they are moving. Let me choose some different color. So suppose that this is a horizontal ground and this is y axis here, this is y axis and this is x axis, and this is also parallel to y axis. This is also parallel to y axis. One particle is thrown from here with speed, one particle is thrown from here with speed, this is thrown with speed v0, and this angle is theta naught. They are saying angle it is making with positive x axis is theta naught. So, this angle will be theta naught. Another particle is thrown like this, its speed was v and angle it is making from positive x axis means this angle is 180 minus theta 1, 180 minus theta 1. So, this angle will be theta 1, simply theta 1. Now, they are saying this point is 0 0, particle moving in xy plane, and this particle is L0 means x coordinate of this point is L. So, technically they are trying to say that this distance is L. Now, the speed with which particle, see what we will do now, we will break velocity of both the particle independently in y and x direction. So, what will be the velocity of particle 1 along y axis? It will be v0 sin theta naught, and along x axis will be v0 cos theta 1. Velocity of this particle along negative x axis will be v cos theta 1, and along y axis will be v sin theta 1. Now, see what is the condition. They are saying that both particles should collide. So, if we want both particles to collide, what is the condition of collision? The only one condition of collision is at same time particles should be at the same position. So, if collision is along one dimension, two particles are moving along one dimension, we want collision. So, x coordinate of both particles should be same at same time. If we want two particles to collide in a plane, then x and y coordinate both should be same for the both particle at the same time. And if we want any particle to collide in space, 3-dimension space, then at the same time x, y and z coordinate of both particles should be same. So, here whole motion will be in a plane, because there is no z axis, and particle is not moving at any time along the z axis, particle is only moving in x y plane. So, at the same time x and y both coordinate of the particle should be same. So, now what we will do, if we want x, let us first solve in y coordinate. We want both the particle, see initial y coordinate of both the particle is 0, this particle is also initially at 0 in y axis, this is also at 0. So, if we want both the particle to collide, they should travel equal distance in equal time along the y axis. And if we want two particles to travel equal distance in equal time, then their initial velocity and acceleration both should be equal. If we want two particles to travel equal distance in equal time, distance is s is equal to ut plus half at square. If I want two particles to travel equal distance in equal time, then u and acceleration, initial velocity and acceleration both should be equal. But here we can clearly see acceleration is same for both the particle along y axis, it will be downward g. So, acceleration is same. So, second condition should be speed of both particle, initial velocity of both the particle along the y axis should be same. So, case 1, this will be valid for both cases. Case 1, let us solve here. Initial velocity of this particle is v naught Sine theta naught is, they have given in case 1 theta naught and theta 1 both are 45 degree. So V naught sine 45 is equal to V sine 45, V sine 45. So from this we can say V naught will be equal to V. V naught will be equal to V. Now along x direction, see, as I told you, if we want these two particles to collide, their x coordinate and y coordinate both should be same at same time. So if initial velocity V naught is equal to V, then y coordinate of both particles will be same. But still, if x coordinate is not same, they will not collide. So x coordinate should also be same. So their x coordinate will be same. If we want these two particles to meet along x dimension 2, means if their x coordinate should be same, then in the same time the distance covered by this particle plus distance covered by this particle should be same, because they are moving towards each other. So total distance covered should be L. So T1 can be written as total distance L and divided by V naught cos theta 1. So theta 1, this is theta naught, not theta 1. V naught cos theta naught is 45, so cos 45 is 1 by root 2, so it will become V naught by root 2 plus, both velocity will be added, both are moving towards each other, so both are covering the distance and total distance covered by both particles should be L, plus its velocity will be how much? V naught, V cos theta 1, and we have already said V is equal to V naught, so we can also write this also as V naught by root 2. So when we will solve this, we are going to get T1 is equal to L by root 2 V naught. When you will solve this, you will get V naught by root 2 plus V naught by root 2, 2 V naught by root 2, which will become root 2 V naught. Now, if we solve this for second condition, when angle is 60 and 30, so when theta naught is 60, so again we will impose the same condition, right here case 2, when angle is 60 and 30. So when angle is 60, this angle theta naught is 60, so V naught sine 60, V naught sine 60 should be equal to V sine 30, second, this angle is 30, so V sine 30, put both the value, so we are going to get V naught sine 60 is root 3 by 2 is equal to V sine 30 is 1 by 2. So from this we will get V is equal to actually root 3 V naught. Now again we will write the total time taken by this particle to move will be total distance covered divided by relative velocity. Here also we have used relative velocity, velocity 1 plus velocity of these, sum of these two velocity. Whenever two particles are moving towards each other, their relative velocity is sum of their velocity. So here also sum of their velocity V naught cos theta naught. So theta naught here is 60 degree. So V naught cos 60 is half. So V naught by 2 plus V cos theta 1. So V is root 3 V naught. So root 3 V naught and cos theta 1 is 30 and cos 30 is root 3 by 2. So root 3 by 2. So actually here we are going to get T2 is equal to L divided by V naught by 2 plus root 3 into root 3, 3 V naught by 2. So 3 plus 1, 4 V naught by 2. So it will become actually 2 V naught. Now if you calculate T1 by T2, so you will get L by root 2 V naught and multiplied by 2 V naught by L. So L will become cancel, V naught cancel, 2 by root 2 is equal to root 2, or we can write T1 by T2 whole square is equal to 2. So correct answer for this question is 2. I hope you understand what concept we have applied in this question. If we want any two particles to collide, they should be present at same time at the same position. Like if you want to meet your friend, at the same time both of you should be at the same position. It's not like you are at your friend's home and your friend is at your own home. So how will you meet? You cannot meet him. So if two particles want to collide, they should be at the same position at the same time. If in one dimension, same x axis, same x coordinate. If in two dimension, same x y coordinate, or if three dimension, same x y and z. All three coordinates should be same. Then we'll divide the velocity into two parts. independently for y and independently for x. So along the y axis, if we want these two particles to cover equal distance, because initially y coordinate of both the particle is same, we want their y coordinate to remain same, so they should travel equal distance along y axis. And if we want them to travel equal distance along y axis, they should have equal initial velocity and equal acceleration. Acceleration is already equal, so only we want equal velocity. So we have imposed condition on velocity v naught sin 45 is equal to v sin 45, and then we have developed time taken by first particle, time taken by second particle, and time taken in first case and time taken by in second case, and T1 by T2 square is 2. I hope you understand.